Hi friends, today we are going to see about the light propagation through optical fiber. Okay, for this, let's see about the optical fiber. So see this is the structure of optical fiber. The inner cylindrical shape is the core and the outer one is the cladding. And N1 is the refractive index of core and N2 is the refractive index of cladding. So the refractive index of core is always greater than refractive index of cladding, that is N1 is greater than N2. So the core is a denser medium and cladding is a rarer medium. So in between this core and cladding we have the boundary, that is called core cladding boundary, and this dotted line is the core axis. Okay, so the inner one is core and the outer cylindrical shape is called cladding. So this is the structure of optical fiber. Okay, so now we are going to see about what are the three process takes place inside the optical fiber when the light ray travels from core to cladding medium. Okay, for this we must know about the critical angle. Okay, so first of all, what is mean by critical angle? For this I am considering a core medium and another one cladding medium. So N1 is the refractive index of core and N2 is the refractive index of cladding. Okay, so critical angle means it is the particular angle of incidence for which the light ray travels along the core cladding boundary. That is, the angle of refraction is equal to 90 degree. So that is called critical angle. So critical angle means this is the particular angle of incidence for which the light ray travels along the core cladding boundary when it incidents on this boundary. Okay, so for this theta I is the angle of incidence, it is equal to theta C means critical angle. So when theta I equal to theta C, the light ray travels along the boundary. Okay, so this angle is called critical angle. Okay, and next we see about the processes. So first one, same, when light ray travels from core to cladding. When travels from core to cladding, it incidents on this boundary. So when it incidents at an angle equal to critical angle, the light ray travels along the boundary and its angle of refraction is equal to 90 degree. Okay, so this is the first process. For all the process we have N1 is greater than N2. And second process, same core medium, cladding medium, and this is the boundary. It's the refractive index N1 for core N1 and for cladding N2. Second process is when the light ray incidents on this boundary at an angle is less than critical angle. Means the light ray gets refracted through the cladding medium. So this is the angle of refraction and this is the angle of incidence theta I. When theta I is less than theta C means the light ray refracted through the cladding medium. So this is the second process. And third one, when light ray incidents on this boundary at an angle theta I greater than theta C means the light ray gets reflected back to the original core medium. Okay, so here theta I is the angle of incidence. So an angle of incidence theta I is greater than theta C means the light ray gets reflected back to the original medium. So for this also N1 is greater than N2. For all the process, the refractive index of core is greater than refractive index of cladding. Okay, only the angle of incidence gets differed. Okay, so theta I is greater than theta C means the light gets refracted back and reflected back and forth. So this is the condition for total internal reflection. Total internal reflection is the principle of optical fiber when the light ray transmits through the optical fiber. Okay, so what are the conditions for total internal reflection means? First one, the light should travel from denser medium to rarer medium. and second one is the angle of incidence should be greater than critical angle. So these are the two conditions for achieving total internal reflection. So only by total internal reflection only we can transmit the complete data from one end to another end of the optical fiber without any loss. Okay, so these are the three processes takes place when the light travels from core to cladding medium. Okay, so when light travels from core to cladding, due to the total internal reflection, it gets reflected back and forth like this, and it gets transmitted to the another end without any loss. Okay, so this is about the light propagation through optical fibers. Thank you.